Hey guys! In this video I'm going to show you how to simplify fundamental trig identities using identities that we already know and some that we don't know. So the ones that we already know are actually on page 2 of your packet. They're there for you so you can always refer back to them. But just to remind you, remember we talked about reciprocal identities. You know all of these. Cosecant is the reciprocal of sine and etc. And also you know quotient identities. Tangent is sine over cos, cotan is cos over sine. So keeping those in mind and also introducing a new set of identities for you, which in this video we're going to talk about our Pythagorean identities. We're basically putting some of these together and giving you more identities based on that. So let's go ahead and start off. Number 1 is asking you to simplify sine times cosecant. Now you can kind of ignore the x or the theta, whatever's given to you. It does need to be there, but you can kind of ignore it for now, just for the work. What I'm going to do is I'm going to always write everything in terms of sine and cosine as much as I can. So I'm going to say always use sine and cosine, because then is when you can actually see things that do simplify. Okay, so then on number 1, sine is just sine. I know cosecant, though, can be written as 1 over sine. And I'm just going to bring the sign that was in the front, I'm going to bring that down and put it over 1, because now I know that sine and sine cancel, leaving me with 1, and that's my answer. Number 2, I have a sine at the top. I can't really do anything with that. At the bottom, though, I have a cos times tangent. Now, cos, again, I can't do anything with, but tangent I can write as sine over cos. So let me rewrite everything that I can't change. And I know tangent is, like I said, sine over cos, which helps me because I can kind of ignore the sign that's at the very top for now, writing cosine at the bottom over 1. And just like we did for number 1, the cosines cancel, leaving you with sine over sine, which also cancel, leaving you with 1. Number 3, if I scan through, these are all trig functions that are being multiplied by with each other. So let me go in and see what I can write in terms of sine and cosine. So I know I can write tangent in terms of sine over cos. Cosecant is 1 over sine. Cosine, though, is just cosine. So let's go in and write down what I can't change and then go back and actually change things that I can. Now let's see. So tangent is sine over cos. Cosecant is 1 over sine. And let me put this cos at the very end over 1 so it looks a little bit better. So let's see. Sines cancel, coses cancel, leaving me again with just 1. Number 4. So these are, well, this one and number 5 actually, these two do introduce to you the Pythagorean identities. So let's take a look at number 4. See that sine squared, you have minus cos squared. Whenever you see sine and cos together and they're both squared, chances are that they probably have something to do with your Pythagorean identities. Also, if you see any other rendition of that Pythagorean identity, always kind of think back and see, okay, maybe there's something I can do with this. Sometimes what you have to do is actually manipulate these Pythagorean identities because you won't see them as is. Sometimes you do have to actually change them. For example, on number 4, it looks very similar. The only difference really is that minus sign, and I can't just ignore that or change it to a plus and act like it wasn't a minus in the beginning. I do have to actually work with it. So what I'm going to have to do is manipulate this so that maybe I can work with it a little bit later. So on number 4, if I try to rewrite that a simpler way, what I'm going to do is I'm going to say, okay, I'm going to treat this as sine as A for now, just to make it a little bit easier. And I'm going to call cos B, just for right now, because I know things get confusing when you see sine squared and cos squared and things like that. So let's just simplify it. So really what I'm given is, in terms of A and B, A squared minus B squared over A plus B. Okay, so now let me see if I can simplify that. Now, there's something that I can do, and I know it's been a while, but I can actually factor that. This is the difference of two squares. So this does factor to a plus b and a minus b over what was already there, a plus b. So what ends up happening is the a plus b factors cancel, leaving you with a minus b. So that was a very general way of looking at it. Now if I apply back into it what I'm really working with, which is sine and cos, really I have sine squared of x minus cos squared of x over sine of x plus cos of x. This, just like we did earlier, does factor to sine of x minus, or I'm sorry, plus cos of x times sine of x minus cos of x, all over what was already there, which is sine of x plus cos of x. And just like we did with the a's and b's, here too, that factor cancels, leaving you with sine of x minus cos of x. So there's your answer for that one. Let me just write that down here so we have it for later. Okay, number 5. So again, I see a cos squared, so chances are I can probably use my Pythagorean identities from up top. So I see a 1 and I see cos, so maybe there's some way I can manipulate this. In other words, maybe I can rewrite this so that I can work with it very well. So let me look at that and see if I can work with it, because I want to manipulate this equation so that it says what we have in our problem, which is 1 minus cos squared. So let me see if I can do that. If I simply subtract cos squared on both sides, oops, just like that, it goes away from here, giving me what I want actually on the right side, which is 1 minus cos squared. And on the right side, that's actually equal to sine squared of theta. So now what we're going to do is we're going to use this as a substitution almost, where 1 minus cos squared can be written as sine squared of theta. So now if I go into my problem, all of this I can write as sine squared of theta or x. In this case, I'm going to use x because that's what they use in the problem, over the sine of x that was already there. So now I'm going to try to simplify. So I have 2 sines at the top, 1 sine at the bottom, so I can actually simplify that so that I have just 1 sine remaining at the top and nothing else. And there you go. Number 6 we're going to ignore for right now. We'll come back to that on another day. Number 7, again, you want to rewrite everything in terms of sine and cos. So let's see, I can write cosecant in terms of 1 over sine. Cotangent I can write as cosine over sine. So let me go ahead and do that. Here I have 1 over sine of x minus cos of x that I can't do anything to, and cos of x over sine of x. Okay, so here I'm going to put this cos that was already there that I can't really change. I'm going to put that over 1. And so let's see, I have, really I can't cancel anything. The first fraction is going to remain 1 over sine of x minus, okay, over here I'm going to have to multiply. So I have cos times cos, which is actually cos squared, over 1 times sine, which is sine of x. So now all I can do really is combine my fraction so that it comes down to one simplified fraction. So if I do that, I do have a common factor, or a common denominator, so I don't have to mess with that. Sine of x is my denominator. Now at the top I just have 1 minus cos squared of x. Now that should look very familiar. Check back on number 5. We simplified that a little bit earlier. If you need to go back to that part of the video, go ahead and go back now. But it does simplify. That top does simplify to sine squared of x, and the bottom is still sine of x, and this basically turns into that problem actually. and you end up with a simple sine of x. Number 8, you have two fractions there, no squares, so I know I can't use the Pythagorean theorem, at least not right now. But what I need to do is, to be able to do anything actually, the only thing I can do right now is get a common denominator. So to be able to do anything, I need to get a common denominator. So because they both have ones, they both have sine, I can't just say, oh, let me just add a negative somewhere. Okay, I can't do that because 1 plus sine and 1 minus sine are actually units by themselves. So what I need to do is multiply the entire first fraction by this entire denominator. So I'm going to multiply my first fraction by 1 minus sine, top and bottom. And my second fraction I'm going to multiply by this denominator, 1 plus sine, top and bottom. So now if I simplify, let's see, in my first fraction I have 1 minus sine of x at the top. At the bottom, when I multiply these, I'm going to have to actually factor. So really I have 1 minus sine of x times 1 plus sine of x, which does simplify, and I'll do that in a minute. In my second fraction I have 1 plus sine of x at the top. And again, that same set of factors at the bottom, so 1 minus sine of x times 1 plus sine of x. Now let me just do this because I know I don't have a lot of room on my paper, so let me just do this kind of on the side here. I'll show you how those factor. So my denominator does actually, not factor, I'm sorry, it does FOIL. So I have 1 minus sine of x times 1 plus sine of x, and this is coming straight from your denominator. So if I FOIL this, my first terms give me 1, my outer terms give me plus sine of x, inner gives me negative sine of x, and then last terms give me minus or a negative sine squared of x. So hopefully you see in the middle, they do cancel. You have sine and sine that cancel, leaving you with 1 minus sine squared. Now this, again, should look familiar to you because you have a sine squared and a 1. So perhaps we can pull in that your Pythagorean identity again. And now find a way to simplify 1 minus sine squared. Okay, so now I'm going to actually subtract the sine squared over, leaving me with cos squared theta here, and giving me what I have right here, 1 minus sine squared on the right side. So again, just like we did before, I'm going to use cosine squared to represent the 1 minus sine squared that I have. So I'm going to write that really as cos squared of x, actually, in this case. So let me transfer that to my paper here. I have this first fraction, 1 minus sine of x over cos squared of x, plus my second fraction, 1 plus sine of x, and at the bottom we simplify that also to cos squared of x. Now that I have a common denominator, I can go ahead and put them together. So my common denominator is cos squared of x, and at the top I'm going to add. So I have 1 plus 1, which is 2, negative sine of x plus sine of x actually cancel. These cancel, leaving me with 2 over cos squared of x, which is a completely fine, it's a completely okay answer. However, it's actually even better to take it further if you can see it this way. I'm going to pull this fraction apart so that I see two terms kind of separated. So I'm going to write this as 2 times 1 over cos squared. Now the reason why I do that is because I can simplify this, rewrite it, so that 1 over cos squared is represented as secant squared, with the 2 still there. So that would be the most simplified version. However, I will take this. I will accept that as an answer if you don't see this instead. Okay. Number 9, also, we're going to skip for now. Now number 10, we've already done this in a previous problem. Number 10 is asking you to rewrite this fraction so that it's not in fraction form anymore. And that's actually what we did on the very last example, actually. So what we want to do is somehow get this 1 plus sign out of the bottom so that there's no longer a fraction. So now there's no square that I can work with. I can't really use the Pythagorean theorem right now, but I can force this to become something that I can use the Pythagorean identity on. So what I'm going to do is I'm going to multiply top and bottom by the conjugate of the bottom. So I'm going to multiply top and bottom by, so I'm just rewriting right now. The conjugate of the bottom would be the same thing that's there, except I'm going to change the sign in the middle. So its conjugate would be 1 minus sine of x. And I'm going to multiply top and bottom by that. And so if I do that, at the top I get 1 minus sine of x. At the bottom, though, I get to FOIL. And so we've already FOILed. If you want to take a look back at the previous couple of minutes in the video, go ahead and do that. But it does give you, once you FOIL, 1 minus sine squared of x, which is really nice because now again, 1 minus sine squared, hopefully you know, is from the Pythagorean identity. And it can be written as cos squared of x. And that's at the bottom of my fraction. At the top, I still have 1 minus sine of x. Get it out of a fraction. So what I'm going to do is I'm going to have to see that, okay, I have one term at the bottom, two terms at the top. I can't pull apart the top, but I can share the denominator with everything at the top. So what I'm going to do is I'm going to say, let's actually use cos squared as the denominator for 1 and the denominator for sine. So what I mean is I'm going to write this as 1 over cos squared of x, keep the minus, sine of x over cos squared as well. So now I still have fractions. I know it looks even worse, but you can always go back and simplify this. So I know cos squared at the bottom, 1 over cos squared is actually just secant squared, just like we did before. And actually, I can rewrite this fraction as well, kind of like what I did up here. I can pull it apart. So I'm going to pull this second fraction apart like this, so that I have sine of x times 1 over cos squared of x, like that. And hopefully you'll see now 1 over cos squared, again, I can write as secant squared. And let me write in everything else. And so there we go. We've reduced it. It's no longer in fraction form. Go ahead and try number 11.